All right, hide, boom, boom. So, section 3.5, symmetry. Boom. All right, here we go. The last section of this chapter happens to be the easiest section of this chapter, which is really nice. Most of the people yesterday got their homework done in about 10 minutes or so. So it wasn't too bad. So we're going to talk about symmetry today, which is reflectional symmetry and rotational symmetry. When something goes on top of itself, when you can fold it so it's on top of itself, or when you can turn it so it's on top of itself. So reflectional symmetry is symmetry for which a reflection maps a figure onto itself. The line of reflection for a symmetry is called the line of symmetry. Okay? So, we can flip it this way and it's on top of itself, or we can flip it this way and it's on top of itself. So it has two lines of symmetry. Depending on the shape, it could have one line of symmetry, a couple lines of symmetry, or it could have 10 lines of symmetry, as you'll see in a little bit. Rotational symmetry is when a figure is mapped onto itself where it's less than 360. Because if you make a full turn of 360 degrees, it's not symmetrical. If you can only make a turn of 360, then it's not symmetrical. But if you can turn it anything less than 360 degrees and it's on top of itself, then it has rotational symmetry. All right. So, if we look at this decagon down here, and we look at all the lines of symmetry, starting with K, which goes point to point across here, and this one goes middle to middle. We can fold it like this, we can fold it like this, we can fold it like this, and so on. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lines of symmetry for a decagon. A decagon will have 10 lines of symmetry, okay? Because you can fold it 10 different ways across itself. Now, if we talk about rotational symmetry, how far do we turn it until it's on top of itself again? So we would turn K not to M, but to N, because point to point. So it's the same point to point, okay? So we could turn K to N, which is 1, 2, 3, 4, 5, 6, 7, 8, 9. Because if we go back here, that's not symmetry because it's back on top of where it started. So it has 9 sets of rotational symmetry and 10 lines of reflectional symmetry. Okay? 9 sets of rotational symmetry and 10 lines of reflectional symmetry. Okay? So the rotations are 36, 72, 108, and so on. Well, how do we figure that out? Well, how many degrees are there in a circle? 360. How many sides are there on this? 10. So every 36 degrees, you're going to have rotational symmetry. So 36, and 36 times 2 is 72. 36 times 3 is 108. 36 times 4 is 144, and so on. So those are your 9 rotational symmetries. And here are your 10 lines of symmetry. So looking at this, how many lines of symmetry will this have? How many lines of symmetry is this arrow going to have? Just the one, just the folding down. You can't fold it over that way and be symmetrical. How much rotational symmetry does this have? Does this have rotational symmetry? And the answer is no. When you rotate it, it's not on top of itself until you get back to the start again. So it's one line of symmetry and no rotational symmetry. One line of symmetry and no rotational symmetry. Okay? This one, how many lines of symmetry does it have? 4. 1, 2, 3, 4. When it has an even number of sides, you can split it angle to angle, or you can split it down the middle of a side when there's an even number of sides. So a 4-sided figure will have 4 reflectional symmetries. So it has 4 reflectional symmetries. How many rotational symmetries? P could go to S, and then to this, and then to this. So how many rotations? 3 rotations. At 90, 180, and 270. Because if I have 4 sides, you take 360 divided by 4, and then every 90, that's 90 degrees. So every 90 degrees, it rotates on itself. So a hexagon. How many lines of symmetry will a hexagon have if it has 6 sides? 6, according to Jenny. I bet Jenny's right. 1. Then you go through the middle because it's an even number of sides. 2, 3, 4, 5, 6 lines of symmetry. Okay? So rotational symmetry. Rotational symmetry. How many rotations can you make? Starting here. Well, 1, and then you go to 3, which is 2, 3, 4, 1, 2, 3, 4, 5 rotations, right? How many degrees do you go each rotation? Well, there's 360 degrees in a circle. How many sides are there? 6, so you go every 60 degrees. So there's 60 degrees, 120 degrees, 180 degrees, 240 degrees, and 300 degrees. A triangle. How many, let's do reflectional symmetry on the triangle. How many reflections can we make on a triangle if it's 3-sided? Now, if there's an odd number of sides, you can go right down the point, and then through this point, and then through this point. So how many reflections, lines of reflection? 3 for reflectional. And how big are the rotations for rotational? Well, there, 360 divided by 3 is 120, so they're every 120 degrees. So it's 120 and 240, and you can't be 360, so there's only 2 rotations for rotational symmetry. You'll have one that looks kind of like this on the test. It's a five-sided flower. How many lines of reflection will we have on a five-sided flower? 5. 1, 2, 3, 4, 5. Okay, 5 reflectional. And how many rotational? Well, we can turn it this far, this far, this far, and this far. So there are 4 rotations. What are the rotations? Okay. What's 360 divided by 5? 360 divided by 5. You know how many degrees that is? Might need your calculator today. Nope. 72. So it has rotational symmetry at 72, 144, 216, 288. Okay. This star has how many points? 7. So how many lines of symmetry? 7. How many rotations of symmetry? 6. So you take 360 divided by that, and you should be good. Okay. That's it for today. Next time, we're going to do a practice test, plus we're going to do your vocab test over the chapter. So you're going to have a vocab test next time. So be ready for the vocab test next time, because we'll take the vocab next time. Okay, I said it 6 times. Hopefully you know.